Picking up where we left off from yesterday, okay? You guys supposed to finish up these problems along with your homework, okay? So let's just go over this very, very quickly. Remember, whenever it's the inverse, remember arc sine also means sine inverse. So whenever you see arc sine or arc cosine or arc tangent, they just mean cosine to negative 1, sine to negative 1, etc., etc. So remember the restrictions. Sine is restricted between what two values? Negative power of 2 to power of 2. Cosine is restricted between
0 and pi.
0 and pi, and then tangent is restricted between
Negative pi over 2 and pi over 2. Not included.
not included, okay? So you basically have to ask yourself, on that interval from negative pi over 2 to positive pi over 2, where is sine 1 half? And I'm just going to call on some random people. Hopefully you guys finished it later. Pi over 6. That is correct. You're basically looking for a y value. Where's 1 half? That is pi over 6. The next one, arc sine, aka sine to the negative 1 of negative root 2 over 2. That would be where, Caleb?
I don't know. I didn't do it.
No, wait, hold on. You can still do it though.
Okay.
Where is sine negative?
Sine negative on the quarter 4 down the bottom.
Down the bottom. And remember, there's 3 here. Where are always your root 2's?
In the middle.
In the middle. So if we remember, it's a negative pi over 2. So what is this value right here in the middle?
That'd be pi over 4.
Mhm. It's going to be negative.
Oh, okay.
There we go. So even if you can't do it, I'm going to help guide you to that answer, okay? It's good thinking right here if you're in a circle. This next one, sine inverse 2, not 2, sine inverse of 3. Michael.
That was mine. Not.
And why not?
I didn't quite get the inverse part.
Shut up.
I'm trying to think. So that would be in quadrant 4, right?
Well, what are your ordered pairs for any of these? Like we already know this one is, the root 2's, right? What's this one here?
That one would be root 3 over 2.
And
Root 1 over 2.
1 half.
No,
Okay.
1 half.
And then this one will be what?
The opposite of that, so 1 half and then root 3 over 2.
And of course you do have your negatives, of course, here in the fourth quadrant. Now, are any of these 3? So if none of them are 3, then can we really take sine inverse of 3? So then our answer will be what?
Undefined.
Undefined, not possible. MP. Arc sine. Sine inverse of square root 3 over 2. Where is that, Angie?
Negative
Negative what? Careful. It's a positive.
That was a
Sine is positive in the fourth of first quadrant.
I put negative.
Well, it was a positive. So where would the positive be? Would it be in the fourth quadrant or the first quadrant? First. And so you were right on the value, but it would just be the positive version. So it would be a power of 6. I thought you said something different. Power of 3. It's a positive.
I just put negative.
You're right.
You might have wrote down that it was a negative. Yeah. So it's just the opposite. Alright, we're gonna skip B, come back to E. What about arc sine of -1? How about Donnie? What is that one?
Negative pi over 2.
Very good. And those are the signs. Question. We'll come back to this one. Question on the signs. Yes.
How do you know it's negative pi over 2 and not positive pi over 2?
Because it was a -1. A positive pi over 2 sign is a positive one.
Okay, thank you. Yeah, I get it.
Alright, cosine inverse of negative root 2 over 2. Seth, where is that?
3 pi over 4.
That is correct. Because remember, cosine is bounded to this upper part of the unit circle. Very good. What about cosine inverse of -2? Tanner? It is not possible. The same reason why 3 wasn't possible for For sine. What about the cosine inverse of 0, Anna? Wait, what? Say again? Not 1. Remember, 0 is actually not like 0 pi. It's actually like the number 0. So it's asking where on your unit circle would cosine be 0, where that x value is 0. Not at 0. Just what is lower pair right here? Oh, you need a circle. Okay, looks like I need to change that a little bit. Alright, and this one here? 0, 1. This one here? Very good. So where is our x value 0? And that is? And that is where? Pi over 2. There we go. Alright, cosine inverse question.
Why is it that one instead of the one that's right? Why is it at 90 degrees instead of at
270? Because remember, cosine inverse. We talked about this yesterday. On the inverse, the domain is restricted between 0 to pi. So we don't even include any of those that are on the outside. Alright? This one here, cosine of negative 1 of this particular value, Brianna. Pi power 6. Good stuff. And this one here, cosine inverse of 2.5, Monica. It is not possible. Same reason why H and C were not possible. Cosine inverse of negative 1/2. Christian. Yeah, It's all right. Well, question on the last one or question on this one? Okay. All right. Here we go. To the inner circle. Where's cosine negative? First quadrant or second quadrant? Second. We know we have 3. What's this order pair right here? Square root of 2. So it looks like we have our answer, right? Because the cosine are x coordinates. So right here, what's that angle? 2 pi over 3. That is our answer. Good stuff. Questions? Tangent. The next one. I'll take a volunteer for M because that one was a little bit, you had to do a little work there. You had to think about that one. Kaylee, what is the tangent inverse of negative root 3 over 3? Huh? Right. It is negative pi over 6. What you say nothing? I had to think about it because that's why I made that face.
You wanted to embarrass me.
Well,
Just in case it was wrong.
alright. Well, how about this, Kaylee? What about tangent inverse of negative 1? Where's that? It is negative pi over 4. Good stuff. Alright? Now, this one over here, E, is sine inverse of negative 2 pi. Sine inverse of negative 2 pi. Anyone? What'd you get? What'd you get for that one? E, the one that I skipped. Not possible?
But it should be.
What's the interval for sine inverse?
I don't know. Negative 1 to 1. Oh, I put not positive, but I
It's
mean,
1 to 1 or
obviously-
negative pi over 2 to pi over 2 and pi over 2. So it's not like a 1 1.
So-
It's outside of the negative.
Exactly, it's outside of it. It is technically 0, but it's about the rotation there.
Yeah, I mean, I put not possible, but then I look back.
So, I want to talk about this particular problem from your notes the other day. Because when one of my coworkers went to go watch the video, because she was teaching this to her class, she said, hey, I heard one of your students in the back say, why is that if it's not in the restriction? So I want to make sure I address this, okay? I do. So everyone, stay with me here, okay? You guys remember what the answer was for this one?
1.1.
It was a positive 1.1. And let me show you why, okay? This right here is basically a composition, right? We're plugging one function into another function, okay? And the best way for me to talk about it, just to make sure we kind of clear up any issues, this will also help with a problem from the homework. I think it was number 18, okay?
That was tangent. 17 was 17's cosine.
Okay, here we go. So, to do these problems, remember at the very front of your notes, right? You had the list with basically these compositions, right? You had cosine inverse and then cosine of x equals x, and you had like sine inverse, parentheses, sine x equals x. You had all those, right? Basically, in order to do problems like this, you need to recognize that, hey, basically, a lot of these, the cosine and the cosine inverse are just going to cancel out, okay? That's what happened with this problem. Remember the answer was just -4? That's because it followed that property that says tangent of tangent inverse of x equals x. We knew that this was -4, okay? We just used our calculator to confirm it. So it's about knowing those properties that when you have that type of combination, a lot of times the cosine and cosine inverse or the sine and sine inverse will cancel each other out. But in these types of situations, the reason why it wasn't a -1.1, it was a positive, I'm about to explain this right now. Look at it this way. When you're doing compositions, even if you forget that those are the properties, you can always start on the inside and work your way out. So, take away just this part right now, okay? Just take it away, pretend like it's not even there. If I ask you, what is the cosine of 5 pi over 3? Knowing you're in a circle, you will tell me what? What's the cosine of 5 pi over 3? It would be, no, that's very true.
That's 1/2.
That is 1/2. Okay, so the cosine of 5 pi over 3 is 1/2, right? Is everybody with me? So, remember there was a cosine inverse on the outside. So basically what we did is we actually figured out what that value was, replaced it with this. Now I'm going to ask you, what's the cosine inverse of 1/2? It's the inverse. No, it's the inverse. Inverse of cosine is restricted between what?
0 and pi.
0 and pi. So where from 0 to pi on your unit circle is cosine 1/2? You guys didn't say unit circle, did you? It's pi over 3. And that would be your answer. This is another way to figure this out just in case you forget the properties, the stuff that's on that front page. You can start with the inside, figure out what that is, and then do the outside.
But what if they have brackets?
What do you mean, right?
That's the same thing as something.
Yeah, same thing, Chris. The same thing. Alright, look at this one. Start on the inside. What's the cosine of 7 pi over 6? -√3/2. So we're going to replace the inside with exactly that. We actually evaluated it. And then we're going to do the cosine inverse of that. Where on the interval from 0 to pi is cosine a -√3/2? So your answer for this is 5 pi over 6. Okay? Now the only reason why I'm doing it this way is because originally, do these lie in this interval? Does 5 pi over 3 lie in this interval and the 7 pi over 6 lie in this interval? No, but that doesn't mean that it's not possible. It just means that, hey, you're going to have to work your way from the inside to the outside. Yeah, basically I'm simplifying inside and then evaluating from the outside. Now for this one, the reason why it's a positive, now I know you're thinking, well, -1.1 is now your unit circle. That's correct, okay? I'm not disagreeing with you here, okay? But my next question is, in your 4 quadrants, does anybody know where -1.1 is?
Or second one.
It's in the 4th quadrant. Good stuff.
Oh,
Okay.
that's what you just said. I was asking.
It's in the 4th quadrant. I said, where is it? You said 4 quadrants.
Oh, I thought you said it was.
Well, I did. Why don't you?
No, it's just repeating.
All right. Now, if you're like, well, how are you supposed to know where these are? You can always convert it back to a degree. You know, there's many ways you can just figure that out. Okay. Now, again, yes, it's not on the unit circle, but it is close to one of the values that we know that are on the unit circle. Okay. So let's just say that this is close to 5 pi over 3. Or maybe even negative pi over 3. It doesn't matter. Okay? Can you guys tell me what's the cosine of 5 pi over 3? Wow. Literally?
√2.
Cosine's positive in the fourth quadrant.
Oh, that's right.
What is the cosine inverse of 1/2? Pi over 3. It takes you to a point that corresponds to that exact same point in the first quadrant, the positive value. Did everybody catch that? Every single one of these works out that way. Look at 5 pi over 6. 5 pi over 3. When we did that one, we got pi over 3, didn't we? 5 pi over 3, pi over 3. Look at 7 pi over 6. Where's 7 pi over 6? Which quadrant? Third. But the answer to this one was 5 pi over 6. Ooh, the positive version within the interval. Is everybody with me? So then if this is a negative 1.1, then the value that it corresponds to is this positive version up here in the first quadrant, which is a positive 1.1. Okay?
So you can say that
Mm-hmm.
Average.
Yeah, especially if the value does not lie in your interval. Okay? I want everyone to go grab a whiteboard. What about something like this? It's mixed ones, but it shouldn't throw you off any. Using that same method, start with the inside. What's the sign of pi over 3? So then what's the cosine inverse of root 3 over 2? Where is cosine of positive root 3 over 2? Positive.
Oh, is that X?
That is x.
11 pi over 6. Oh, pi over 6.
Pi over 6. Because it has to still fall in the interval from 0 to pi. So you can do ones that are mixed trig functions, but these are, you really are going to have to go inside out. Because you're mixing. And you still have your restriction of your inverse. Okay? And the calculator will not tell you the right answer.
So it wouldn't be 11 pi over 6, but it's because it's 5.
Because it's outside of the interval for the inverse. It has to fall in that interval.
I have a question. Are you gonna give us like an empty answer?
No, but you can easily flip over on the back of something.
Is our test next week?
Yes, it is. On Wednesday. Alright, real quick, Brianna, do one of those. Wait, start over. Sign what? Oh. Then what? So this? Okay. This is number 25 on your homework. Okay? This is another one where you have to start inside, work your way out. You have to ask yourself, what is the inverse cosine of root 2 over 2? You're still on the restriction. Where's cosine root 2 over 2?
Pi over 4.
Pi over 4. That 2 on the outside means you're going to multiply it to pi over 4.
Pi over 2.
That's going to be pi over 2. So now you ask yourself, what's the sign of pi over 2? And that's your answer.
1.
So you just work with the inside going out. 2 times the cosine inverse. That's how you get these respective values. Okay? And that's how you had to do those. Look at this one. It says to find the exact value of cosine sine inverse of negative 1/2. Okay? This particular value is negative 1/2 on your unit circle. Yes, it is. Where? What angle does it fit?
Oh, it's
Negative 1/2 would be 200 degrees.
Okay, so we need this particular one because it has to fall in the interval. What's this angle?
300 degrees, or negative 11 pi over 6. Or 11 pi over 6. Sorry.
It's pi over 6, specifically negative pi over 6. That is where,
going the other way. It's not completely around.
exactly,
Yeah.
because we are still on the restriction.
Oh my god. I was just looking at what.
So, if that is a negative pi over 6, what is the cosine of that value? What's the cosine of negative pi over 6? What's the cosine?
Root 3 over 2.
Root 3 3/2. No restrictions here. It was normal cosine. So basically, you just had to tell me the x value of that particular angle. Okay?
Yeah, it was inverse.
Yeah, it was just inverse sine, but not the inverse of cosine. Now, this one could be done using unit circle because that value is on a unit circle. But there's another way you can do it. That's why this coordinate plane is here. What you can do is something that we talked about before your midterm, where you could create a triangle. You guys remember doing this?
Yes.
And then labeling our sides? Throwback. Sine is what over what? Think triangles. Think
Opposite over hypotenuse.
very good. Opposite over hypotenuse. Okay, this is going back here. Your opposite side is going to be 1. Your hypotenuse is going to be 2. But more specifically, your opposite side is going to be a -1. Why? Well, you're in the 4th quadrant. In the 4th quadrant, wouldn't this be negative?
Yes.
Okay. Now, if I know 2 sides out of the 3, how do I find the 3rd side?
I agree.
-1 squared plus x squared equals 2 squared. What's -1 squared?
1.
And 2 squared?
4.
Subtract. Take the square root. X is going to equal a √3. Now remember, it's always plus or minus. But because I'm in the 4th quadrant, my x is on what?
Over 2.
Positive or negative?
Positive.
Positive. So another way to tackle this particular type of problem is you could have drawn a triangle, labeled your sides, and then the triangle would take care of the inside part. Because in order to create this triangle, we use the inside part. So now all you have to ask yourself is, what's the cosine of this triangle? Cosine is what over what?
Adjacent over hypotenuse.
And it's the adjacent side of √3. And it's the hypotenuse too. So it works the same way. Let's do another one. Look at this one. Is 5/13 on unit circle? No. When it's not on unit circle, you have to do a triangle. There's no other way to do it. Okay? And it is an inverse. So that should also tell you, hey, I need to make a triangle. I'm in the 1st quadrant because both things are positive.
Yeah.
Cosine is what over what?
Adjacent over hypotenuse.
So
I was gonna say
5 is my adjacent, and 13 is my hypotenuse. I need to find my other side. Pythagorean theorem. 5 squared is?
21.
This is a special right triangle, but 13 squared? What's 69? Subtract? 144. So y is what? And is it positive or negative? Because you're in the 1st quadrant. So, this 12 represents my what side? Opposite. And sine is what over what? So what's the sine of this triangle? And that's your answer. So using a little bit of the old trick stuff that we used to do, now to this new stuff. Pull out your whiteboards. We're going to do one more on your whiteboards. I can squeeze it in.
I like this now.
Yeah. Not that it makes more sense.
I have a question. So is there any word?
I want you guys to do this one on your whiteboards. Hurry, hurry.
Oh, yeah, falling out maybe.
Dick was like. You need that unit or
Yeah, over 6.
Square root of 3 over 2. Square root of 3 over 2. Don't quote me on that.
5 over 4.
5 over 6, 3 over 2. Square root of 3 over 2. I know. So I'm gonna say I'm being a little bit late to this period.
Where's your 6th period at?
All the way across campus.
There's another problem for you too, to give a try. Pause the video and try it out.
First page, you and
Coach Gilmore. And she's there for like.
Mike, what was that doing?
This was.
Practice, guys. Practice, practice, practice. That's the only way you'll get good at it. And know your unit circle.